Hi guys, this is our lecture on electrostatics. Let's get started. We are looking at how electricity ties into the model of the atom, the basis for our explanation of electricity and magnetism. So previously we'd mentioned that all atoms are defined by their atomic number, which gives us how many protons are in the center of every atom. A proton is a subatomic particle that has a positive charge. An electron is another subatomic particle that has a negative charge. And so we care about charges in the sense that charges will interact with each other. Why do electrons orbit an atom? Because they are attracted to protons. And why do they spread out in an atom? Because electrons don't like other electrons. In fact, what drives electricity and magnetism, and we mean literally drives it, the pushes and pulls that gets electricity to move, electrons to move, is the electrical force, which comes from a fundamental rule which says like charges repel and opposites attract. And so to start with, we have to understand that our atoms are made up of protons, which are positively charged, and electrons that are negatively charged. Okay? And in our normal state of being, objects are typically neutral. They have an equal number of protons and electrons. And we saw that previously. For a helium atom, such as this, we have 2 protons and 2 electrons in its normal state. But objects that have an unequal number of electrons and protons are electrically charged. And once objects have maybe, for instance, too many electrons, right? Maybe this helium atom had a third electron, then we start to see some interesting physics occur. Electrons will start moving around a little bit more, and when we get moving electrons, we have electricity. Okay? So the question is, if we have an unequal number of electrons and protons, our object is overall charged. How do we charge an object? We just add or remove electrons. Okay, let's do a couple of quick check questions before we go any further. So we make sure we have the concept of charges down in our head. All right, question 1 says, label the charge interactions to the right as attractive or repulsive. All right, our rule is like repels like, and opposites attract. All right, we'll do the first one for you. Here we go. So we have a proton and another proton. Okay, like repels like, so this is going to be repulsion. Here we have a proton and an electron, and we have an electron and an electron. All right, go ahead and attempt it on your own. Okay, we have attraction here, and we have repulsion here. Not too bad. Okay, question 2 says the presence of a net charge in an object means that they will A, experience an unbalanced non-zero electrical force, or B, experience a balanced net zero electrical force, aka no force at all. Well, if we have a net charge, that means we have too many or too few electrons, and then we're going to have our atom try to balance itself through an electrical force. So our answer is A. Okay, so we have a principle underlying this, which is the principle of conservation of charge. If moving electrons around is how we get a net positive or a net negative charge, net negative, too many electrons, net positive, too few. Well, electrons can't be created nor destroyed, but are simply transferred from one material to the next. Okay, friction is one of the ways that we do this. Previously, we had seen a plastic rod and a wool rag. And the method through which we look at why a plastic rod versus a wool rag will maybe move electrons around through friction, well, it really depends on the material properties. A plastic rod is made up of different atoms than a wool rod, right? And so the plastic rod has more affinity for electrons, right? Maybe it has more protons than our wool. And so it's going to grab onto those electrons from the wool and it's going to steal them, okay? And here we have something called the triboelectric series. This can allow us to predict what objects, when rubbed together, are going to steal electrons and which ones are going to donate electrons. But let's see very quickly, to remind ourselves, what the result of this looks like. Okay, so we saw our demo, and we have the charged plastic rod will cause the tinsel to float. Okay, question 3, why did the tinsel float in the in-person experiment? Our answer is A, friction caused the rod to become negatively charged. This resulted in an unbalanced electrical force, a push, on the rod and tinsel. Not too bad. So we knew that there was a force between the rod and the tinsel. Why? Because if there wasn't, the tinsel would have just fallen straight to the ground, right? There must have been something opposing gravity. And that something is our electrical force. Like repels like, opposites attract. Well, the electrical force is something that's described by what we call Coulombs Law. In particular, Coulombs Law states that the force between, say, positive and positive charges, or negative and positive, between any charges, varies directly as the product of the charges, and inversely as the square of the distance between them. What does this mean? Well, electrical force is often compared to gravity. We know gravity to be an attractive force only, right? This object is moving in an orbit around the planet, but why does it stay in orbit? Because it's attracted by gravity. Why do electrons stay around protons? Because they're attracted to the protons. And just like gravity, we think to ourselves, if I'm further and further away from Earth, doesn't the force of gravity decrease? It certainly does. And so if you were to take that tinsel really far away from the charged rod, would the tinsel float if you're really far away? No, it doesn't. So just like the force of gravity, we have a nice equation for the force of gravity, which we can see depends on masses and distance. Well, we have a sort of beautiful symmetry here where the force of the electrical force also depends on distance. It depends on the magnitude of the charges of our electrons and protons, okay? And the further away you get between charges, just like the further away you get between masses, the electrical force will decrease, okay? And as we said in the past in class, the electrical force is, right, like 1 billion times stronger than the force of gravity. And yet the force of gravity shapes the moon and the sun we see as giant spheres. Even the Earth is mostly spherical, right? Why is that the case? Because, as we said before, objects are mostly neutral. They have an equal number of protons and electrons. And so how do we get them to not be neutral? Well, we have 3 methods of doing this. We've seen the first one, friction. When you rub 2 objects, the object with the stronger pull for electrons will steal the electrons of the other object. Let's see that one last time. Okay, so our comb stole the electrons from the cat's fur. Our second way of charging, moving electrons around, is simply through contact. All right. So if we have a net charge on one object and we touch it to another object, those electrons are like, "No, man, I don't like you. Please get away from me." And those electrons are going to jump into that second neutral object, which is now going to become charged. Let's take a quick look at this. This is an animation I made. I like it. Okay. So charging by contact is our third way of moving electrons around. And then we have our second way. Then we have our third way, which is charging by induction. And this is the really cool one, because it shows that electrical force is truly like the force of gravity. It acts at a distance. Gravity doesn't require contact, neither does electrical force. Okay? And so if you bring a charged object even near another object, right? Your charged object, maybe it has too many electrons. Those electrons are going to push on the electrons in our second object and cause the electrons in the second object to repel, and therefore moving the electrons around, and now your second object is charged as well. And so induction is just an example of charging an object at a distance. Let's go ahead and see that real quick. All right, it's incredible. You can move electrons around even without touching. The electrical force, described by like repels like, opposites attract, acts at a distance just like the force of gravity. Wow. Okay? So to summarize very quickly, because we get a lot of information, electrical force occurs between charges, which we get from the model of the atom. Protons in the center are positively charged. Electrons are negatively charged. We have like repels like, opposites attract, which we can see here. Okay? The electrical force is like 1 billion times stronger than the force of gravity, and yet the force of gravity rules the day. It shapes our universe. Why? Because most objects are normally neutral, and therefore don't experience a net electrical force on it. Okay, but you can give an object a net charge and therefore cause it to experience a net electrical force by adding electrons, which makes an object net negative, and subtracting electrons, which makes the object net positive. All right, and one quick thing. As we look more and more into electricity, electricity is really just the movement of electrons. All right, good job, guys. We'll see you next time.